Lesson 96, we're going to look at changing dimensions on perimeter and areas in different polygons. Now I'm only going to look at one example because I think you'll get the idea. You just kind of got to basically do what it's telling you to do. And you just got to visualize how it's telling you to draw it. So example one, let's try to go through this. A rectangle is half as tall as it is long. Okay, so I'm going to just kind of draw the shape a little bit. It's half as tall as it is long. So its length is doubled the width. Or sorry, its length is half of the width. So if so let's look at this first part. All right, we're on this sentence. A rectangle is half as tall as it is long. Well, what I'm going to do here is it's not going to give us any dimensions. It's not going to say your length is 5 or width is 12 or whatever. It's just going to say it's half as tall as it is long. So I'm going to say 1/2 x and x. The reason being, okay, my length, I'm going to give that as my original, variable. All I know about width. All I know about the length is that it is half what the length is. Okay, great. Sorry, I keep using the wrong words. All I know about the length is it's half what the width is. So I can call this 1/2 x on both sides. It's a rectangle, and I can call that x. So that's how I basically draw that sentence. Then it says if its height is reduced by 1/2 its original height. Okay, so now we have a new rectangle, and it says its height is reduced by 1/2. Well, what's 1/2 of 1/2? It'd be 1/4. So my new height is 1/4 x. It didn't say anything about my length. It just said my height is reduced by half. It wants to know what is the ratio of the new rectangle. All right, here's my new perimeter to the old, or the original. All right, what is the ratio of the two perimeters? So yes, it doesn't give any numbers specifically for the length and width, but we can still know the ratio even just using the variables. So when I add all these together, x plus x is 2x, plus both of these halves. This ratio is 3. I can say 3x if I want, but 3. This ratio, well, the perimeter here is 2 and 1/2. So I'm going to say 2.5. So the ratio of the two perimeters is a 3 to 2.5 ratio. If I wanted to make it whole numbers, I could multiply it by 2 and say it's 6 to 5 ratio. But those are the same thing. It didn't necessarily ask for it to be in whole numbers. But that's all you're doing on these. You're just trying to dictate what it's telling you to do. For example, I'll just do one more example 3. It says a circle's radius is increased by a factor of 3. So here's my original radius. And it says we have a new circle that's radius is 3 times as long as this one. Find the ratio of the circle's new area and circumference to the original area and circumference. So from this point, okay, let's do circumference first. So circumference is 2 pi r. So I'm going to do it for both of these. Well, we're just calling this one r. So here's my ratio here. My ratio here, well, this r, we're plugging in 3r. And so 3 times 2 is 6 pi r. This one's 2 pi r. Okay? So there's my two circumferences. So when I reduce, well, my pi and r's can cancel out because those are the same. So it is a 1 to 3 ratio for my circumference perimeter. and really that's the same kind of as that problem. Doing area, all right, formula for area, pi r squared. Area over here, pi, I'm going to go ahead and plug in 3r squared. Since my radius is 3r. So this ends up becoming pi 9r squared. And we're still left with pi r squared over here. So those are my two areas. So when I reduce, once again, the pi and the r squared can basically cross out. When I cross all that out with, I'm just left with a 1 right there. Okay, if I divide it all by pi r squared, I'm left with 1 for the area there. For the area here, I'm left with 9. So this is a 1 to 9 ratio for the area, 1 to 3 ratio for the perimeter. And so that is how you do, that's how you change, or the effects of changing dimensions on perimeter and area for these polygons.